So in the last lecture, I have given you the introduction for your new method, that is your Newton method. So we have done that the approximation in this iteration formula becomes your xn plus 1 is equal to xn minus function value at xn and divided it by its derivative at xn, and then you can start from 0, 1, 2 up to so on, right? I have already told you that the order of convergence in this case is your 2. Likewise, in fixed point iteration method, you also need here one initial approximation, that is your x naught. So choosing the x naught, that can be the same criteria that you can use your intermediate value theorem कि आपका उसमें रूट लाए भी करता है कि नहीं, so that you can start from any approximation in that interval, right? So we will do example related to this. So apply Newton's method. Apply Newton's method such that f of x star is less than 10 raised to the power minus 8 for f of x is equal to cos x minus xex, right? So now we have given a function. The function is my cos x minus xex. अब यहाँ पे जो स्टॉपिंग क्राइटेरिया है, दैट इज नॉट योर एब्सोल्यूट एरर. आपका स्टॉपिंग क्राइटेरिया क्या है कि फंक्शन में आप क्या इनपुट कर रहे हो, जो भी आपका x आएगा, अगर आपकी फंक्शन की वैल्यू लेस देन 10 रेज टू द पावर माइनस 8 आ जाती है, देन यू विल स्टॉप ओवर हियर, राइट? सो द स्टॉपिंग क्राइटेरिया कैन एनीथिंग. It can be your absolute error, it can be your relative error, or you can also substitute in the function कि आपको इतने zeros के near by answer मिल जाए. So since when we have to apply the Newton's method, right, I need the first initial approximation that I have to start, right? So I cannot say कि इसका root किस में lie कर रहा है, but you can guess from the intermediate value theorem. You can check कि आपका f0 पे आपका आंसर आ रहा है 1, that is your greater than 0, and at f1 you have answer is minus 2 point something and that is less than 0. That means definitely your root is lying between 0 to 1. So you can start with any initial approximation in the interval 0 to 1. ऐसा भी हो सकता है कि आपने approximation जैसे कोई भी लेनी है, नहीं दी हुई, तो आप क्या करोगे, आप ऐसा इनिशियल अप्रोक्सीमेशन ले लोगे जहां पे वो आपका रूट लाए नहीं करा, तो आपका मेथड आप लगा तो दोगे बट इट विल नॉट कन्वर्ज टुवर्ड्स योर रूट, राइट? सो यू हैव टू स्टार्ट द इनिशियल अप्रोक्सीमेशन जहां पे आपका रूट लाए करता है. So since your root lying is between 0 to 1, you can start with any initial approximation. Suppose I am taking x naught is equal to 1. So what is our formula? That is xn plus 1, xn minus function's value at xn divided it by its derivative at xn. Now that means this is equal to xn. फंक्शन की वैल्यू xn में का मतलब क्या है, दैट इट इज cos xn minus xn e की पावर xn divided it by its derivative. The derivative of cos will be minus sin xn, and here when you will apply your product rule x into ex, so you will have, right? So ultimately when you have to start the initial approximation, अब आपका क्या निकलेगा, x1 आएगा. x1 क्या है, you will substitute n is equal to 0 in this case. When you will substitute n equal to 0, तो यहाँ पे क्या आ जाएगा आपका x naught, और x naught की वैल्यू आपकी क्या है 1 minus cos of 1 minus 1 into e raised to the power 1 divided it by minus sin 1 minus 1 into e1 minus e. Whenever you have to deal with your trigonometric ratios for solving the question, please convert your calculator in the radians mode. So when you will calculate this value, it is coming out to be your 0.0 65307940. Why I am taking more terms in this? Because मुझे फंक्शन की वैल्यू कहां तक चेक करनी है, 10⁻⁻8 से लेस करनी है। अगर आप सिर्फ 3 और 4 वैल्यूज ही लोगे तो आप कैसे चेक करोगे 10⁻⁻8 से वो कम है या नहीं? सो इट वुड बी बेटर टू टेक मोर वैल्यू। सो यू कैन चेक, यहाँ पे आपकी फंक्शन की वैल्यू अगर आप x1 की सब्स्टिट्यूट कर रहे हो, दिस वैल्यू, दैट मीन्स दिस इज योर x1। अब आप इस फंक्शन में सब्स्टिट्यूट कर रहे हो, so the answer is giving as 0.460 something, so it is not less than my 10⁻⁻8, that means I can't stop over here. नेक्स्ट आइट्रेशन आपकी क्या हो जाएगी, x2। अब आपका सब्स्टिट्यूट क्या होगा, x1 की वैल्यू आपकी क्या है, 0 पॉइंट, दैट मीन्स दिस इज 0.65307940 माइनस cos of this thing minus x into this thing and your e raised to the power this quantity divided it by sine of this quantity minus, that means you will substitute here your x1 value. So when you will calculate this is coming out to be your 0.53134337, right? Now again you will check the function value at x2. So function value at x2 is coming out to be 0.4180, that is also not less than 10⁻⁻8, that means you can't stop over here. Again you will perform the iteration x3. अब आप फंक्शन में क्या सब्स्टिट्यूट करोगे, योर न्यू वैल्यू x2, आपका क्या हो जाएगा, x2 माइनस द वैल्यू ऑफ दिस and in its derivative. So when you will calculate, this is coming out to be your 0.5179091. So now this is your new value. You will check the function's value at x3. So it is coming out to be your minus 0.4641, which is also not less than 10⁻⁻8. You can also perform next iteration. नेक्स्ट आइट्रेशन में अब आपका सब्स्टिट्यूशन क्या होगा, दैट इज योर वैल्यू ऑफ x3, द फंक्शंस वैल्यू एट x3 डिवाइडेड इट्स बाय डेरिवेटिव. सो व्हेन यू विल कैलकुलेट, दिस इज कमिंग आउट टू बी योर 0.51775,738. Again you will check the function's value at x4. So it is coming out to be your 0.59 26 into 10⁻⁻. Here it is also my into 10⁻⁻1 into 10⁻⁻3 into 10⁻⁻7, which is not less than 10⁻⁻8. So you will perform one more iteration. So here your answer is coming out to be your 0.51775736. Now again you will check the function's value at x5. So it is giving me 0.2910 into 10⁻⁻10, which is now less than 10⁻⁻8. That means you can stop your iteration over here. So your approximate root of the function, the approximate root of cos x minus xex is 0.51775736. So since you are saying this is approximate error, इसीलिए इसका आंसर आ रहा है 0.00000, your 10 times 0 and then it is value is it occurring. So it is very close to 0. तो वहां पे आपका रूट सेटिस्फाई हो रहा है, that means this is your answer. Is it clear? Next. We can do one more example. use Newton's method. Use Newton's method to find a non-zero solution of x is equal to 2 sin x. So because 0 is always the solution of this, when you will say x is equal to 0, that will be equal to your this 0. That means x minus 2 sin x is your function. So 0 is always the solution. But आपको कौन सा solution निकालना है? That is your non-zero solution. So the iteration says that you have xn plus 1 is equal to xn minus function's value at xn divided it by derivative of f dash x n, and n is from your 0, 1, 2 up to so on. So you can check that at f1 and f2 is your less than 0, so your root lies between 1 to 2 interval. So you can start with any initial approximation in this interval. Suppose I am taking x naught as my 1.1 in this interval 1 to 2. So the iteration formula becomes xn plus 1. This is my xn. The function is xn minus 2 sin xn and divided it by derivative, that is my 1 minus 2 cos xn. So when we will start substituting n equal to 0, I will have the initial approximation x1, that is my x naught, which is 1.1 minus 1.1 minus 2 sin 1.1 divided it by 1 minus 2 cos 1.1. So when you will calculate its value, it is coming out to be your 8.453. And when you will calculate x2, that means you will substitute the value of x1 in this iteration formula. So this becomes x2, that will be your this, that is coming out to be your 5.256. If you perform your iteration again, the answer is coming out to be your 203.384. If you perform one more iteration, and continuing this, अगर आप x5 भी निकाल रहे हो, it is 87.471. x6 is your minus 203.637. आपका रूट किस में लाई कर रहा था? Your root were lying between 1 and 2. It is not approaching towards your root. Therefore, this iteration method it diverges. Why it diverges? Because when we have selected x naught 1.1, your this function at 1.1 is nearly equal to 0. So when you are dividing a number nearly equal to 0, the numerator values will get more values, so your error will increase. So you can write, since we have choosing x naught as your 1.0475, that at pi by 3 approximate value, it leads to disaster. Since 1 minus 2 cos of x naught is equal to 0, therefore x1 does not exist because your f dash x at that point is nearly equal to 0, right? So selecting your initial approximation in this method also plays an important role, so that your derivative should not be equal to 0. क्योंकि अगर आपका derivative nearly equal 0 होगा, that will गिव इंक्रीमेंट टू योर न्यूमिनेटर, तो वो आपका मेथड क्या करेगा, डाइवर्ज करेगा, राइट. सो इफ यू कैन स्टार्ट हियर with the initial approximation not nearby this, if I am starting the initial approximation x naught is equal to 1.5, if I'll calculate x1 in the same way, that is x naught minus 1.2 sin x naught divided it by your this value 1 minus 2 cos x naught. So your x1 is coming out to be your 2.076558, and if you perform the next iteration, so when you perform the next iteration, that means when you will substitute the x1 value in the xn formula, it is giving me answer as 1.910.507. If you find x3 by substituting the value of x2 in your function, so it is giving me answer as 1.895622. x4 is giving me answer as 1.895494. x5, so you can see from here the difference between your x5 minus x4 is less than or equal to 10 raised to the power minus 3, right. So यहाँ पे आपका जो difference है, that means you are converges towards the root. Is it clear? Yes or no? Selecting your initial approximation so that your derivative should not become zero, it also plays an important role. Next example on the same way we are doing. That use Newton's method. Use Newton's method. कन्वर्जेंस की क्या, अगर यहाँ पे एब्सोल्यूट एरर होता कि योर रूट शुड सेटिस्फाई दैट योर एरर शुड बी less than equal to 10 raised to the power minus 3, then it is stopped at this iteration. ये रूट ही तो है, ये फंक्शन वाली वैल्यू नहीं ली मैंने. दैट वाज द प्रीवियस केस जब मैंने फंक्शन की वैल्यू सब्स्टिट्यूट करी थी. बिकॉज हेयर this was the example and I have given the condition that I have to check for this thing. आपको स्टॉप तब करना है जब आपका ये सेटिस्फाई हो जाएगा. यहाँ पे आप स्टॉप कर रहे हो when you have, you can say your absolute error is less than 10 raised to the power minus 3. So the next example, use Newton's method to solve the equation. To solve the equation which is x raised to the power 100 equal to 0 using initial approximation. Using initial approximation x naught is equal to 0.1. Calculate its 5 iterations. So you have to check in the exams what is your stopping criteria. ठीक है, अगर स्टॉपिंग क्राइटेरिया एब्सोल्यूट एरर है, दैट मींस जब आप आइट्रेशन कर रहे हो आप पिछले वाले एरर से एब्सोल्यूट एरर चेक करोगे. अगर स्टॉपिंग क्राइटेरिया रिलेटिव एरर है तब आप रिलेटिव एरर कैलकुलेट चेक करोगे कि आप चेक करोगे xn प्लस 1 माइनस xn आपका टॉलरेंस से कम है, या स्टॉपिंग क्राइटेरिया हो सकता है कि आप ये चेक करो xn प्लस 1 माइनस xn लेस देन एप्सिलॉन है ऑन बेस ऑफ योर एब्सोल्यूट एरर, या ये भी हो सकता है कि xn स्टार लेस देन आपका टॉलरेंस लेवल हो, या आपको सीधा ही नंबर ऑफ आइट्रेशंस दी जाएंगी कि इतनी आइट्रेशंस परफॉर्म करो. इट विल बी गिवन. सो अल्टीमेटली इफ इट इज नॉट गिवन you can if it is not given, you can stop that we are taking the accuracy level 10 raised to the power minus stop, and we are checking the absolute error. You can mention and you can stop there, right? If it is not mentioned, right? So now since here the stopping criteria is that you have to perform 5 iterations. The second part is that you have to use Newton's method to solve the equation 3x raised to the power 1 by 3 equal to 0 using the same approximation x naught equal to 0.1, and you have to calculate the 5 iterations same way. So when we will start, because the iteration method here says xn plus 1 is equal to xn minus function's value at xn divided its by derivative. So when you are doing the first part, but it will be your xn plus 1, function is your x raised to the power 100 divided its by derivative, that will be your 100x raised to the power 99. Solving this, you will get 99 by 100 xn. So we have to start with the initial approximation 0.1. So when I take x equal to 0, my x1 will be 99 by 100. My x naught, and my x naught is 0.1. When you calculate, it is 0.0099. When you will calculate, your x2, so your x2 is coming out to be, when you substitute this value here, so your x2 is coming out to be your 0.09801. x3 is coming out to be your 0.0970299. x4 is coming out to be your 0.096059601. x5 is coming out to be your 0.095099905. x raised to the power 100 equal to 0. When you have to solve, what is the solution? X raised to the power 100 equal to 0. What should be the value of x so that it comes out to be 0? 0. Exactly. So you can notice over here कि आपके न्यूटन्स मेथड की जो थी कन्वर्जेंस, आप कह रहे थे ऑर्डर ऑफ कन्वर्जेंस इज 2, राइट? You have performed your 5 iterations, still you are not nearby to your 0, right? Why it is so? So you can notice over here the progress is very slow. Here the progress is slow. The root, obviously the root is 0, but even after 5 iterations, or 5 steps, we are not closer to the root. Why it is occurring so? Because you are saying x is equal to 0 and f dash at 0 is also your 0. That's why your progress is very slow. It will converge, but it will take lot of iterations to converge that. This is the reason क्योंकि आपका f dash 0 जो है वो क्या है आपका 100x raised to the power 99, and it is 0 at your x is equal to 0. That's why your convergence is slow. In the previous case, it was occurring that it diverges. Here it is converging, but convergence is slow just because at the root your derivative is 0, right? The next, same way, the next part we have xn plus 1, xn, the function is my 3xn, that is raised to the power 1 by 3. When I'll find its derivative, it will be my So when you will solve it, this is coming out to be your xn minus 3xn and this is your minus 2xn. So when we will take n equal to 0 and we are finding the first approximation, so this is coming out to be 0.2. ये इसको सॉल्व करा है, ये क्वेश्चन तो दिया हुआ है ना फंक्शन कि आपको इसकी रूट निकालनी है. The function is given to you that you have to find the value of 3x 1 by 3. तो ये आपका फंक्शन हो गया. That I have substituted in the function. That is my 3x. क्योंकि मैं xn plus 1 ले रही हूँ, xn आएगा यहाँ पे. So it is xn 1 by 3 by its derivative. ठीक है. That will be your, when you will solve this. So your x1 is coming out to be your 0.2. x2 is coming out to be your 0.4. x3 is coming out to be your 0.8. x4 is your 1.6. Here the same is occurring. Why? So it is your oscillating sequence and it is not converging to root. The same reason why? Because ये तो आपने मैनुअली सॉल्व कर लिया, xn की आपने -2x. जब आप कंप्यूटर में इनपुट दोगे तो वो तो डिवाइड ही करेगा, देन इट विल सब्ट्रैक्ट. फर्स्टली इट विल डिवाइड, देन इट विल सब्ट्रैक्ट. सो यू कैन नोटिस हियर कि जब आप इनिशियल अप्रोक्सीमेशन यहाँ पे x0 आपने 0.1 लिया था, व्हेन यू विल स्टार्ट, दिस इज द सेम रीजन कि आपका f' 0 पे 3x 1 by 3 की रूट भी क्या है, 0 ही है. This will only satisfy when your x. So even at your root, this is your value is 0. So that's why it is diverging from the root. So it can occur in both ways. Either it can diverge or if it will converge, the convergence will slow. अगर आपकी डेरिवेटिव पे वैल्यू क्या आ रही होगी, 0 के अप्रोक्सीमेट आ रही होगी. Clear? Newton method is clear. Fine. Next we are doing modified Newton's method. Modified Newton method is, जो अभी तक आपने क्वेश्चन किए हैं वो सिर्फ आपको एक ही रूट दे रहे हैं. That means if you have a simple root, right? So modified Newton method is for multiple roots. So here the formula changes. We will not drive that formula. I'll tell you what will be your formula. So it occurs in two ways. When you know the multiplicity of the root, when you don't know the multiplicity of root. मल्टीप्लिसिटी आई हैव टोल्ड यू इन द स्टार्टिंग लेक्चर कि आपका मल्टीपल रूट क्या होता है. मल्टीपल रूट क्या होता है कि जैसे अगर मैंने डेरिवेटिव निकाला, ठीक है, अगर आपका फर्स्ट डेरिवेटिव उस रूट पे 0 आ रहा है, सेकंड डेरिवेटिव आपका 0 आ रहा है, सपोज आपका थर्ड डेरिवेटिव क्या आ गया, नॉन जीरो आ गया, तो उस रूट की मल्टीप्लिसिटी कितनी हो जाएगी, 3, राइट? सो दैट यू कैन डू इन टू वेज कि अगर आपको पता है कि फंक्शन की मल्टीपल रूट्स आ रही हैं और उसकी मल्टीप्लिसिटी आपको पता है कितनी है, देन योर फॉर्मूला चेंजेस. xn plus 1 xn minus multiply, this is your multiplicity, the function's value at xn divided it by the function's value its derivative. And when you don't know the multiplicity, आपको ये पता है कि मल्टीपल रूट है बट उसकी आपको मल्टीप्लिसिटी नहीं पता कि कितनी मल्टीप्लिसिटी है, then you can use the formula xn minus function's value at xn, function's derivative value at xn, divided it by f dash xn whole square minus or you can remember like this, the function is f dash square minus f into f double dash. So f minus f dash whole square minus f into f dash. This you will use when you don't know the multiplicity of the root. This you use when you know कि आपकी जो रूट अकर हो रही है वो आपकी मल्टीपल रूट्स है और उसकी मल्टीप्लिसिटी कितनी है 2. यू वांट टू डू एग्जांपल्स की मल्टीप्लिसिटी कैसे निकालते हैं, दैट आई हैव ऑलरेडी टोल्ड यू इन द प्रीवियस लेक्चर की हमने मल्टीप्लिसिटी कैसे निकालनी है. यू कैन ऑल्सो वेरीफाई कि आपका अगर क्वेश्चन एफ ऑफ एक्स इक्वल टू एक्स क्यूब माइनस 3x स्क्वायर प्लस 3x माइनस 1, you check that find the multiplicity of 1, right? If you calculate f1 it is coming out to be your 0 क्योंकि 1 उसका रूट है. If you calculate f dash 1 this is also coming out to be your 0. If you calculate your double derivative this is also coming out to be your 0. If you calculate the triple derivative that is coming out to be your 6 which is your non-zero. That means 1 is multiple root with multiplicity. कितनी multiplicity है 3 because your third order derivative is non-zero. Is it clear? अगर आपको पता है कि मल्टीपल रूट है और आप सिंपल न्यूटन मेथड लगा रहे हो, ठीक है, तो ये नहीं है कि वो कन्वर्ज नहीं करेगा. इट विल कन्वर्ज बट द कन्वर्जेंस विल स्लो irrespective of this. ठीक है, we can solve one example that the question is given to you. Solve f of x is equal to ex minus x minus 1. Show that f has a 0. 0 means root, right? F has a 0 of multiplicity. Either you can say roots or you can zeros. With multiplicity 2 at x is equal to 0. Show that Newton's method x naught at x naught equal to, when you take x naught equal to 1, converges so you have to show that the function is ex minus x minus 1. You have to find the root और आपको पता है कि x is equal to 0 पे उसकी multiplicity कितनी है 2. So if you apply your simple Newton's method, what your simple Newton's method says, xn minus the function's value at xn divided it by derivative. This is your simple Newton method. So if you apply your simple Newton's method, when we will start x naught, that is your 1, right? We calculate your x1, that is your, substitute the value, that is your 1, minus the function value, that is e1 minus 1 minus 1, and its derivative, that will be e raised to the power 1 and minus 1. The derivative of this will be x minus 1. So when you will calculate, this is coming out to be your 0.58198. And if you perform 16 iterations, even then your answer is 10 less than 10 raised to the power minus 6. जो भी आपका आंसर आ रहा होगा, that is coming out to be, or the 16th iteration is coming out to be your 1.949 into 10 raised to the power minus 6. So here your error is this. But now you know कि आपकी multiplicity x is equal to 0 पे कितनी है 2. So you can modify the formula. xn plus 1 आपका फॉर्मूला क्या बन जाएगा, xn माइनस मल्टीप्लिसिटी कितनी है 2. So you will multiply 2 the function's value at xn, divided it by derivative, and you can notice over here कि आपका 13 iterations पे ही you will get the answer, that is your so in this at the third iteration, that means x1 you are coming out to be your 0.16395, x2 you got 0.0044781, and x3 here you got 0.000000342. So यहाँ पे आपको 10 raised to the power minus 6 तक पहुंचने के लिए आपको 16 iterations परफॉर्म करनी पड़ी. You can notice over here कि आपका यहाँ पे 10 raised to the power minus 5 के लिए थर्ड iteration पे ही आंसर सेटिस्फाई होगा, राइट. इवन अगर आपको यहाँ पे 10 raised to the power minus 5 चाहिए तो भी आपको 15 iterations परफॉर्म करनी पड़ रही to achieve your accuracy at the 10 raised to the power minus 5. So when you will use this formula, you have just performed 3 iterations and you are nearby your answer. Is it clear? Yes or no? So when you have given कि किसी रूट की इतनी मल्टीप्लिसिटी है, you can change the formula and you can multiply this function with that multiplicity. ठीक है, नहीं करना वो, यही मैं, that's why I have just shown you that is also converging to the root, but the convergence is slow in that case. उसमें आपको iterations तक पहुंचने के लिए 16 iterations परफॉर्म करनी पड़ रही हैं. जब आपने मेथड अपना मॉडिफाई कर दिया, आपका 3 iterations में ही आंसर आ गया. Is it clear? So the next example, if you have function f of x is equal to x cube minus 7x square plus 16x minus 12, apply Newton's method for multiplicity, for multiple roots, and your initial approximation is 1. So now here in this question, आपको पता है कि आपके क्वेश्चन में आपके जो इक्वेशन है उसकी मल्टीपल रूट्स हैं, बट यहाँ पे आपको उसकी मल्टीप्लिसिटी नहीं पता. आप मल्टीप्लिसिटी निकालोगे भी कैसे, आपको तो रूट ही नहीं पता. पिछले में उसने दिया हुआ था कि x इज इक्वल टू 0 आपकी रूट है, वो मल्टीपल रूट्स है, दैट इज योर 2 with multiplicity 2. But here you know that it has multiple roots, but you don't know the multiplicity. If you do not know the multiplicity, we can use the formula xn plus 1 is equal to xn minus f dash square minus f into f double dash, right? So when you will use the formula and you will use x not equal to 1, if you will calculate x1, this is coming out to be your 2.1111, and your x2 is coming out to be your 2.0078, x3 is coming out to be your 2.00003, and suppose you have to check for the accuracy 10 raised to the power minus 3. So you can check here your error between x3 and minus x2, that is less than 10 raised to the power minus 3. So you can stop at this iteration, right? You have changed the formula, the same. अगर आपने यहाँ पे सिंपल वाला फॉर्मूला लगाया होता तब आपकी आइट्रेशंस उतनी ही ज्यादा होती, राइट? सो हियर एट योर थर्ड आइट्रेशन योर आंसर हैज कम. इज इट क्लियर? -3 लिए, सपोज कह दिया, इफ इट इज 10 - 3 आई हैव टेकन दैट, यू कैन कंसीडर इट. Right? So in the 3 iterations you have achieved your root, but इस केस में अगर आपने सिंपल रूट लगाया होता तो आपको जो है number of iterations more it was more. Okay, is it clear? Newton method for simple root, Newton method for multiple root. Is it clear to all? Yes or no? Okay, thank you.